So friends, good morning. A hearty welcome to my YouTube channel. Myself, Dr. M.H. Annaya. Friends, in today's video, we are going to draw the development of a right circular cone whose dimensions are given as 50 millimeter diameter of base and height is equal to 70 millimeter. And let's see what is the question we have for today's video. The question reads like this. A cone diameter of base 50 mm and axis 70 millimeter long. So diameter of the base is given and the height of the solid is also given. Resting on HP is cut by a section plane which is normal to VP. So the cone which is placed on HP on its base is cut by a section plane which is normal to VP, inclined at 60 degrees to HP. So the inclination to HP can be seen only in the front view. Passing through extreme end of base. So there are two extrements. This is one extrement, this is the other extrement. So you can have the section plane passing like this or like this. So we will asked to draw the development of the lateral surface of the portion of cone containing the apex. Apex is this part. Friends, what do we do? We will place the cone on HP and obtain its front and top views. In the top view, the cone appears as a circle, and in the front view, it is going to be a triangle. And here, friends, I have drawn a circle for the given diameter of 50 millimeter. So I can show somewhere here the diameter equal to 50. So I will say 550. 5 indicating the diameter of this circle. And I have divided this periphery into minimum 8 number of parts. If you divide into 12, you get a better curve, but there won't be space to accommodate all these. Hence, I divided this into only 8 equal parts. 1, 2, 3, 4 and 4. And let's name this as A, this is B, C, D, E, F, this is G. O dash is the vertex, O1 dash is the center of the base, the axis is perpendicular to HP. So these parts you can just mark them. This point is A dash, which is obtained by projecting the line through A. This is point E dash. Like that you can get other points like G and C, etc. Say this is G dash and this is also C dash. We'll mark later. Now friend, we have got the front view and top view of the cone. That is the first step. That is initial placing of the object, obtaining its top view and front view. And friends, in the front view, you have so many lines like this. These are all called the generators. Since the circle is divided into 8 equal parts, you will have 8 generators in the development, 8 generators in the top view, and 8 in the front view. I will mark this as O, O1. So we have got the front and top views. Now let us see how the section plane is cutting the solid. So it's cut by a section plane passing through the end of the base. End could be A or E. So I can just draw a line passing through either A dash or E dash, inclined at an angle of 60 degrees to HP. Okay, now what I do? I just write a line, a section plane, passing through one of the extreme ends of the base and inclined at an angle of 60 degrees. This 60 degrees to HP. I will call the section plane yes. Friends, after this is being cut by section plane, you will have to see in the question which part of the cone is to be developed. As per the problem, draw the development of the lateral surface of cone containing the apex. If you don't specify, you can draw the development of the lower part or the upper part. But here we have been asked to retain the part containing the apex, O dash. This is apex. In case of pyramids, we call this as vertex, this is apex. So friends, I will show the part that is retained for development by using visible lines. So this is one line, second, third, fourth, And generally in all the cylinders and cones, we show only the extreme lines of the solid by visible line. So this is the part which is to be developed. The portion above that is to be developed. And I call this as part P. Part P is the part that is to be developed. Friends, after placing the object and after showing the section plate, the next step involves calculation of the sector angle theta given by the formula theta is equal to small r by capital R into 360. So without remembering this formula, nobody can proceed ahead with the development of the solid. Friends, what is this R? R stands for the radius of the base of the cone. This base has a diameter 50 and half of that is small r. This is small r I shown here. So this is 25 by capital R. What is capital R? This R is the length of the end generator or true length of the end generator. And this can be obtained only after construction of this triangle in the front view. Keep a scale between O dash and A dash, find out its length. So this can be obtained multiplied by 360. So you will get some angle. So this can be formed out. That have marked as theta. Now friends, after this, we have to mark this sector depending on this value. So we have to draw a vertical line of length is equal to true length, that is R, and draw that circle or sector having angle theta. So we have to take center O and R as radius. We have to draw an arc, and in that arc it should have an included angle theta. That is, I am going to draw this line first, then mark this line at an angle of theta which is known to us. Then we are going to divide the periphery or this angle, sector angle theta, into the same number of parts as that of the base divided into. So the base is divided into 8 equal parts, and hence we are going to divide this sector having included angle theta also into 8 equal parts. And next comes the positioning or starting of the development, whether to start from O dash A dash or O dash E dash is the question. Generally, friends, you have to start from a point. Excuse. Suppose say here none of the end generators are totally removed, and hence what we can do, we can start with OA, OB, OC, OE, whatever it may be. Say I will start from point A, B, C, D, E, F, G, H, and A again. This is how we have divided. And these are the part B, C, and I will show later. Now, let us see how to mark the development of this. Friends, you can see here, the section plane SS is passing through point A. We have A here. I'll show it by dark line. Again, A we have got here. Is it clear? You have to be very cautious. Then you can see this OB or B and H are the points. This OB and OH are cut here. But OB and OH, the generators are not twin length. Hence, I am going to shift it either to the right or to the left. Okay, I can shift it to the right and mark this point on OB and OH. So, this distance has to be marked from here on OB and also on OH. So, this is on OB and this point is at OH. Then friends, this is the point where the section plane is cutting the generators OC and OG. So these are also not true length. Shift that to the last line and obtain that distance on OC and OG. So this is OC and this is the point OG. So we got these points, and then we have got this point is D and F. So this is OD OF. OD and OF are cut here, but OD and OF are not the true length. Hence, this has to be shifted to the true length line R line. Mark the distance on OD and OF. Next comes OD, and this point is OF. You got the point? Friends, finally, the end generator O dash E dash is cut at this point by the section plane. This is actually the true length. Simply take this distance from O dash to this point on the lot generator. Mark on OE. So friends, we are going to mark it somewhere here. Friends, we have got the points marked on all the 8 generators of this cone. So we are going to join all these by a smooth continuous curve in case of all cylinders and cones. So friends, I am going to join like this. And friends, let's see which portion of the solid is to be shown dark. The last line O dash A dash is to be retained. Hence, I have to show this by a visible line or a dark line. Similarly, OA this side is also to be shown by a dark line. So we have shown this line visible. And what is to be shown by thin line? The complete base is removed here. So all this line, this A to A, should be shown by a very thin line. And in all the generators, not the cones and cylinders, only the extreme lines are to be shown by dark line, and these points are to be joined by a smooth continuous curve. Friends, the portion above this you can see here, this part OA along this curve, and this portion will represent what is called development of P, the portion of the object which has got the apex in it. So we have got this part, apex retained in the development. Friends, in the same question, if you are asked to draw the development of the lower part of this, that is to say from A dash to this section, in this much you are asked to find out, then very obviously if you call this as part P dash, the lower portion, this is the portion, we can say this will be the development of P dash. But as per the question, you have to show this. And if they're asking you to draw the development of the lower part, then this curve has to be shown dark, and this arc should be shown dark, and these two lines are to be shown thin. Hence, in the same problem, we were able to draw the development of two parts of the cone, which is cut by a section plane normal to VP and inclined at an angle of 60 degrees. This angle is 60, I have not shown here. So this is the angle 60 degrees. So since the section plane is normal to VP, it is seen as a line in the front view. Friends, I hope the presentation was interesting. Please go through the complete video. Do not skip any part of the video in between. And if you like this video, please share the information about this video and about my YouTube channel link, namely Engineering Drawing and Machine Design by Dr. MHA. Thank you very much for watching my YouTube video. Have a blessed day.